Okay, now it's time to learn some actual physics terminology. We're going to begin by defining rather specifically two terms, distance and displacement. So, what is distance? Well, first of all, it's a scalar quantity, right? So you know, hopefully, or recall the difference between a scalar and a vector. The scalar quantity that we're dealing with is called distance, right? It represents how far apart two things, positions, instances of space-time are. So the SI unit for it is meters, and it's usually represented with a lowercase s. I think for distance or something. I'm not too sure why, but it's lowercase s. Sometimes you'll see x, sometimes you'll see d. D is the more common alternative. Sometimes you'll see L. There's a lot of other ways it's done, but the formal way is S, so you'll see S a lot, and D is the one you'll see second most. Okay, it's the distance between 2 points. It's a scalar. It means there's no direction, no nothing. It's just distance, right? It's how far away is that thing as the crow flies, they say, so in a straight line. This is contrasted to displacement. So displacement has a direction. It's the displacement of B from A. It's a vector quantity, and it's represented, all right, that little R there, with an S with a hat. So this is S, and then you put a vector hat on it, right? A hat with a little arrow. That's the vector hat. It means it's a vector now. So direction is really important. Okay, so now we have to say it's x meters away in this specific direction or that specific direction, okay? And what I think you'll notice initially is that it actually matters which direction you're going, right? We could say the displacement of B from A is not the same thing as the displacement of A from B. So the displacement of B from A means start at A, how do you get towards B? That's the displacement of B from A. And I'm going to use the of from a lot, okay, when we do forces and relative velocities and all this other stuff, okay? The other way around, if you want of A from B, right, of A from B, the displacement of A from B, it's starting at B and it's going to A. So it's different. Okay, so keep that in mind, that the direction is kind of reversible if you change your language. So that's distance and displacement. So what's the difference, right? Well, one of them, aside from just being a scalar and a vector, right? Like distance and displacement, one could say, in very simple cases like in the previous page, you could say, all right, if you've got a displacement and you want to calculate a distance, you just delete the direction, right? And that's only true for single movement cases, only when you have 2 points you've moved between, you've gone in a straight line, you've done nothing else. It's actually a bit more complicated than that. So typically, we express distance to mean the sum total of all the travel done in a journey. So if you go and do exercise, right, and you've got a step counter on your watch or on your phone, distance is kind of like the step counter. It tells you how much walking you've done. It tells you how far you went, but it doesn't tell you the difference between where you started and where you've ended, right? Displacement is just the difference between the start point and the end point. The in-between doesn't matter at all. So when you are calculating the distance of something, the distance something travels, you need to add up every single step, all right? So add every step. Every step. And this one here, for displacement, it's just the final position minus the initial position. It doesn't matter what else you've done. It just matters where you've ended up relative to where you've started. That's the important difference. For example, I'm going to go home and then come back tomorrow and film some more videos. The distance that I've traveled is probably a fair bit. I don't live too close to UNSW. But the displacement of me is going to be 0 because I'm going to be right back here where I've started. So displacement, just the difference between the start and the end. So let's try an example, okay? And look, it's vectors. You can kind of do this. A student walks 100 meters north, then 50 meters east, then 125 meters south. What's the total distance? And what's the final displacement? So the total distance is you take the scalar of every single vector that we've been given and just add them up. The distance is 100 plus 50 plus 125. Right? It's kind of like the perimeter of a shape. So that's equal to 275 meters. There's no other maths. It's fairly simple. The displacement, on the other hand, we're looking for this vector, right? That went from where we started to where we ended. And we'll need to know its magnitude, and we'll need to know its direction. Now, what we could do is add all 3 of these vectors up, right? We could do it graphically, or we could do it via components. We learned how to do those in the last few videos. But instead, what we're going to do is cheat a little, because I drew us a nice geometric shape, okay? And we can realize that this is 50 meters, because that makes a nice rectangle. And this down here is 25 meters, because this is 100, this is 125, and this part here is also 100, because that's a rectangle. And so actually our displacement is given by this vector. Right? We're at 50 meters here and 25 meters here. 25, there we go. So what we're going to do is simply calculate this vector. The magnitude is going to be the square root of 50 squared plus 25 squared. That's equal to 56 meters. And the angle is going to be the inverse tan of the opposite over the adjacent. So that's 25 divided by 50, which is inverse tan, 25 divided by 50, 26.6 degrees. There we go. So that's the difference between distance and displacement. Distance is just the sum total of all the traveling done by the person, object, or whatever. Displacement is explicitly the difference between the final position and the starting position. That's all for this video. Please do the quiz questions down below, and I'll see you in the next one.